The work I do, including today's, including the one that I continue to do at Automatic, has to do with open source. I created a framework called Socket.io. I want to mention some milestones that maybe not everyone here is aware of. I think it's nice to share, just to put into perspective all the work we've been doing as a community. For example, today I was talking to people that have been sending patches for Socket.io for years now. A lot of companies in Japan that have been contributing a lot to the project, and I want to share some milestones with you.
一番大切な多分人があまり知らないマイルストーンをちょっとシェアしたいです。日本の会社や海外のもいろいろな会社からプリビューリクエストなどをいただいたので、結構大切だと思います。
So one of the biggest examples of Socket.io users is actually Office.com. When they actually migrated to the cloud and they found themselves with a need to do real-time document collaboration, which was actually one of the first use cases that I envisioned for this framework. They now run Word Online and a lot of other chat products that make up the Office 360 suite or Office Online suite on Socket.io.
もともとやろうと思ったブラウザでコラボレーションツール、チャットツール、マイクロソフトさんがやってるで、それは今Socket.ioを使われて動いてます。
And also public companies like Zendesk power all their online interaction and chat for real-time support on Socket.io.
そしてZendeskみたいな他のパブリック会社もSocket.ioをチャットとかのために使います。
And recently, a lot of the growth and interesting things that we've been seeing have been around the so-called Internet of Things. So one of the projects that really caught my eye recently was this hardware device called OpenROV, which is basically a submarine vehicle that's controlled remotely through Socket.io from a browser, for example.
最近よくある IoT、インターネットオブ Things のこともよくSocket.ioを使います。一番目立つ、彼が目立ったのは、そのサブマリンって日本語で何かわからないけど、サブマリンですね。のSocket.ioを使ってるサブマリンですね。
そうです。
ありがとう。
And also, in addition to all the work I've been doing in open source, I decided to apply a lot of the principles of real-time web applications that you guys learned about today to a company called CloudUp, which had as a fundamental principle that we wanted to share files as fast as possible and to render them on every mobile device and every browser in the same way that the person that was sharing the file was seeing them. So a lot of optimization, a lot of these frameworks were applied to the purpose of sharing files. And that's what I sort of want to talk about today. File uploads, in particular, in all the stack and all the pieces of software that we put together to make websites and applications, file uploads remain a very hard problem.
今日紹介したいのは、クラウドのファイルアップロードについてです。相変わらず、そのアップロードは、一番、結構大変な問題なので、それについてを今話ししようと思います。
And Party is a project that I'm starting to sort of bring joy to uploading files, which has traditionally been very difficult or time-consuming or awful to do.
パーティーという新しいフレームワークは、やっとそのファイルアップロードが楽しくなるために開発しています。
And so to give you a little bit of background about it, to begin with, HTTP was not designed to transfer files. And this is sort of one of the reasons that uploading files today is not easy to do or pleasant to do.
ちょっと HTTP の歴史を説明します。HTTP はそのファイルのトランスファーのためには開発されてないので、かなり難しいことです。
As a matter of fact, if we go back to like the very early definition of HTTP, what was called the first specification was called HTTP 0.9, which is an interesting choice for the first specification. It defined it as a byte stream of ASCII characters.
元々の HTTP HTML の 0.9 の、バージョンでは、HTTP は、バイト、文字列、ASCII 文字列のバイトストリームだと書いてあります。
And as the name clearly says, it was meant for transferring hypertext.
そして名前にもテキストが書いてあります。
And I think as an alternative at the time, we used this protocol that now has become increasingly more obscure called FTP.
今あまり使われてない FTP というプロトコルはそのためにあるだと思った。
Which stands for File Transfer
もち
Protocol.
ろん、ファイルトランスファーだからね。
And as a matter of fact, even though it was designed for transfer files, it still had a lot of drawbacks, which is why it fell into disuse and HTTP sort of took over. In particular, some of the limitations were around the fact that it required an extra dedicated TCP connection. So in order to share anything with FTP, you had to set up 2 TCP connections.
FTP はいろいろなことがよくできてないので、例えば TCP コネクションは一つ特別な TCP コネクションがいるとか、いろいろな小さな問題があったので、今日あまり使われてないんですね。
And even though it was designed for transferring files, it also did a very poor job at being very good at transferring files. As an example, it would only allow you to apply compression on text. Any other binary data would be ignored for compression. And a lot of the implementations of the FTP servers were riddled with security problems, and it sort of became less and less popular over time.
FTP はファイルのためだったのに、ファイルのトランスフェアはよくできてない。例えば、コンプレッションは、テキストのファイルだけが動いてるんだけど、バイナリーファイルとかはコンプレッションが動いてない。
And when it came to actually using FTP to deliver assets over the web, it was also problematic because you weren't able to share the same HTTP connection you were using for the text or hypertext to share to download or upload files. So it had a lot more overhead.
同じプロトコルとか TCP コネクションを HTTP と FTP のために使えないから。別のツールとかいろいろなオーバーヘッドが出てました。
And over time, HTTP was modified to gain a lot of the features that actually made it suitable for transferring files. Namely, we are now able to do multi-part uploads of binary data that are separated by content delimiters, and also we're able to get data with different content types other than ASCII text.
HTTP はどんどん良くなりましたので、特にそのムルティパートアップロードサポートが追加になったので、結構良くなりました。
But over time, we haven't seen an equal improvement in terms of how easy or better it's become to actually perform uploads on the web.
ただ、その回線はHTTP だけだったので、ウェブではあまり良くなってません。
So, just to name a few of the features that are missing, that are absolutely required whenever we want to transfer any file of any size from any network connection, the main one that is sort of missing is built-in support for pausing or resuming.
一番大切だと思っているのは、ファイルトランスフェアはポーズとかリスユームはできない。
There's no automatic retrying, so if the upload fails, it's up to you to handle the error.
一度ダウンロードとかアップロードは動いてなかったらまたスタートから始まらないといけないけど、それはオートマティックじゃなくてマニュアルですね。
There's no chunking, so there's no mechanism in place for splitting the file down into discrete pieces.
分けてるのアップロードかダウンロードはできません。
And therefore, since there's no chunking, there is no ability to parallelize the upload within the file itself.
そのチャンクがないからパーツをパラレルでダウンロードもアップロードもできない。
which was not a problem when upload speeds were really bad, because we were never going to have the issue where an upload was not going to be able to fully utilize your upload speed bandwidth.
アップロードの、パフォーマンスは、悪かったから、あまり問題ではなかったんですけど、今、インターネットの線が、速くなったので、かなりプロブレムになりました。
And ultimately, even though we do have compression capabilities for downloading assets from the web through the accept encoding mechanism and content type, we're still not able to send compressed data from client to server.
ダウンロードの時ではコンプレッションが使えますけど、アップロードの時はまだ無理です。
And that makes for a very sad situation when it comes to uploading files.
それは悲しいですね。
And so today I sort of want to propose a solution that I've been thinking about, and it involves something we all know very well, which is JavaScript.
今日ソリューションを紹介したいんです。そのソリューションはみんながよくご存知 JavaScript を使われています。
Which is great.
すごいね。
And so one of the fundamental pieces that we're going to utilize for the solution is actually XML HTTP request 2, which added binary support.
XML HTTP request 2はバイナリーサポートがありますので、それは使える。
And also introduce the ability to listen on progress events for both uploads and downloads, and give the client the ability to understand how much data has been hacked by the TCP connection.
そして進捗のイベントもあります。それでいくらをアップロードされている、いくらダウンロードされているのをリスンできます。
And the other part of the equation is the introduction of the file API, which allows us to manipulate the binary data of the files before the upload actually happens.
そしてファイル API を使ってアップロードする前にそのファイルを書き換えることができます。
And in particular, we're going to be utilizing the API that comes for every file, because a file is a type of blob that is called slice.
すべてのファイルでできるブロブのスライスメソッドを使います。
So Party is basically a project that combines these two APIs to make uploads very easy and very powerful.
パーティーというプロジェクトはその2つの API を使って1つの簡単なシステムのフレームワークです。
The first thing that we are trying to change with Party is the idea of the monolith, going away from a monolithic approach where you want a framework that does everything, including uploads.
一つのフレームワークで、すべて、一つの何でもできるフレームワークじゃなくて、アップロード専用のフレームワークです。
The traditional way that we've been thinking about uploads usually is, I set up the web framework and I add a route or a module within this gigantic framework that takes care of uploads. But Party tries to be a dedicated upload service, which helps in a variety of ways.
もともと Web サーバーの開発の時にそのアップロード専用のルートを作らないといけないし、それは大きなシステムの中ですね。パーティーのはそれと違ってファイルアップロード専用のサービスです。
And the other big departure from the way that we've been thinking about uploads so far is that it's actually more resembling of protocols like BitTorrent in the way it works, rather than just a byte stream over an HTTP request over a single TCP connection.
この新しいシステムは一つのファイルストリームよりBitTorrentみたいなシステムとよく似ています。
The idea of having a monolithic service helps with two fundamental things. One of them is setup, because you are able to launch a separated service that takes care of your uploads and is separated from the rest of your application, and in fact it's independent and can be controlled completely from the UI from client side JavaScript.
パーティーはサービスの理由は別の その自分がやってるアプリケーションと別にローンチできるからです。
And the other part of it is distribution. So when you're uploading from the client, you don't care so much about where the upload is going. You probably care about your app backend receiving a URL of where that object is eventually stored, which if you have been using services like S3, is probably the way that you've been thinking about. You've been thinking about a dedicated object store separated from the core of your application. And distribution becomes increasingly important because you reduce latency between where you are and where you're going to be uploading.
アップロードのことより、どのようにアップロードしたファイルをアクセスするの方が、大切だと思います。S3 を使って、クラウドで、保存するのは、パーティーのサービスはもともとからできます。
And the other big aspect of it is that it is extremely easy to use.
そして、すごく簡単です。
So I'll show you quickly what the server API looks like. Essentially, you're able to mount it onto any node.js HTTP server in a very similar way to how Socket.io works, where you can specify a path, and then you just mount the file upload service onto it. And the other two fundamental capabilities is, one, you think of the file as an incoming stream, even though it's being uploaded in a very sophisticated way because it's being split into chunks that end up in different parts of the file system potentially. And the other part of it is that you're able to attach arbitrary metadata with the upload. So in that way, it resembles a traditional HTTP request.
この簡単なコードでパーティーを使えます。すごくコンプレックスなシステムなんだけど、node.js の開発者のためには、そのファイルアップロードはストリームになります。ストリームにはメタデータもつけます。
And the client API is equally easy as it only makes the assumption that you're operating with a binary JavaScript data structure, which could be a blob, an array buffer, or a file reference.
HTML の方でも、すごく簡単です。特別なシステムより、そのままのトランスファーと考えて十分です。
And unlike the traditional XML HTTP request to approach, it exposes events that are actually relevant to the upload process. For example, the idea that you have to retry or that the upload failed and it has to be restarted from scratch.
普通のアップロードより、ユーザーに大切な情報も出してます。進捗や、もしアップロードができなかったら、その情報もちゃんと、ユーザーに伝えます。
The other big focus of the project is that we actually want to make sure that by implementing all the features that have been missing in traditional uploading approaches, we actually make a big difference in terms of performance.
他のアップロードのやり方より、私たちはすごく早いシステムを作りたいです。
So I was actually testing it today with a deployment of Party that is actually far away from Japan. I decided to upload a large PDF, and as a comparison point, I start with an upload that just goes through XML HTTP request too.
すごく遠いサーバーを使って、日本じゃなくて、すごく遠いサーバーを使って大きな PDF をアップロードしてました。
So essentially what we're doing there is we capture the drag and drop event, we get the file reference, we send it over XML HTTP request. This is a way that most uploads have always been done, and there's no idea that if the upload fails, for example, at 90%, there's anything you can do other than restart it from scratch, which as a developer you have to do yourself.
これはすごく普通なシステムです。だから、その、再起動とかは、すべて手でやらないといけないです。
However, Party introduces new features that work under the hood. In particular, we work with the web worker API to separate the slicing and uploading process. We're able to chunk the file, we're able to divide the file up into chunks, and we're also testing WebSocket for experimental compression support.
テストするために、チャンクのシステムと、 ワーカーのシステムと、今試している WebSocket のインプレメンテーションも、スイッチがあります。
So I'm going to show you the network was here. So for example, that one took about 7 seconds.
7秒ですね。
And I'm going to test it with usually the tests I've been doing here, which are sort of like anecdotal anyways, I see a 2x speed up over a transfer that goes all the way to California.
スピードはハーフになりましたね。カリフォルニアまで。
And all the parameters of the upload are configurable, so you can decide the size of the chunk can be done in a negotiation between the client and the server, whether to enable compression or not, because compression might be detrimental for certain file types, and whether you want to use workers or not.
それはファイル一つ一つ、そのフィーチャーはファイル一つ一つ選べることができます。そしてサーバーとのつながりで、どのフィーチャーを使うのを判断できます。
So the way that we achieve better performance in regular uploads is because we split the file in parts and are able to upload them in parallel in distinct TCP connections.
どうして早いのか、そのファイルはパーツに分けているからです。
This is especially relevant for very large files, specifically in situations where the file, your upload bandwidth is not saturated by one TCP socket trying to upload this large file.
それは大きなファイルとか一つの TCP コネクションだけじゃなくて、いろいろなサーバーとかその間に入ってると大切です。
This has to do with the congestion control mechanism of TCP, which is a sliding window. By starting different connections in parallel, we're able to grow the different sliding windows in parallel and then send as much data as possible, so we maximize the throughput.
TCP のプロトコルの詳しいコードを使って、TCP のスピードをできるだけ、使います。
And the other aspect of how we can achieve superior upload performance is compression. We're testing two different things here. One is the only way that browsers can natively apply compression from data that's sent from client to server is with the deflate extension of the WebSocket protocol that's only enabled for Google Chrome and Safari.
コンプレッションについてですけど、今まだ開発中ですけど、Google Chrome ではWebSocket がディフレートをサポートしています。
And the next possibility is actually to ship a zlib implementation that could actually be fast enough thanks to ASM.js and other improvements in the JavaScript VM performance.
その代わりにzlib を JavaScript で開発して ASM を使って十分速くなるかもしれません。
And of course, the one goal we have is that you don't have to worry about applying the compression yourself, and Party just seamlessly takes care of it.
一つの大切なことは、あなたはそれを考えなくてもいいです。パーティーはそれをやってます。
The other, maybe even more important aspect of splitting up the file into chunks is to increase reliability.
そしてもう一つのもしかしてもっと大切なことは、そのパーツはライアビリティのためには大切です。
So we have to think more about the idea of syncing a file rather than uploading a file. Now that we have it split into different chunks, we can, for example, upon a browser refresh, resume an upload that was like 90% through and only upload the missing blocks of the file that the server doesn't have.
パーツに分けてるから、アップロードより、シンクの言葉が正しいですね。例えば、ブラウザで、ファイルが 90% にアップロードしてからは、普通は全てまたアップロードしないといけないんですけど、うちらの場合では、その最後の 10% だけが足ります。
In the event of, for example, network disconnections or like poor network quality, like in mobile devices, this becomes increasingly important. But we're actually able to even do it across browser refreshes.
コネクションが悪い場合、 特にモバイルの場合では、TCP コネクションがなくなるのが一番大きな問題なので、私たちはページリフレッシュがあってもできます。アップロード進みます。
And also we give the ability to the application to pause and resume arbitrarily.
そしてアプリケーションは自分でポーズかリスームを選べることができます。
One of the ways that we implement this right now is we're able to generate a unique identifier of the file because the file API exposes some important basically identifiers of the file, which are the modified time.
できる理由は、ファイル API は、ファイルの情報をアクセスできるように、ファイル API を使って、ファイルの情報をアクセスできるようになった。それを使って ID を作れます。
The modification date, the name, and the size of the file can together give us the ability to uniquely identify it.
そのファイルはいつ変わったとか、サイズとか、ネームを使って、間違いないような ID は作れます。
And if needed, we have the ability to, for example, apply actual, more sophisticated hashing mechanisms on the file, like CRC32 or MD5, over the binary data that file exposes.
必要であれば、元安全な CRC32 か MD5 のアルゴリズムを使います。プラグインを使って。
The other important aspect of the architecture is that it's, by default, non-blocking.
もう一つの大切なことは、ブラウザをブロックしてない。
We use HTML5 workers whenever possible seamlessly.
HTML5 ワーカーを使っているからです。
The splitting and syncing of the files and all the logic for retrying happens in a dedicated worker thread.
そう、パーツに分けるとか、シンキングはすべてワーカーの中に置かれています。
And the other big important aspect is specifically in order to be able to seamlessly integrate party into existing applications with their own authorization mechanisms is its flexibility.
そして、他のサービスとかによく使うのがもう一つの大切なことです。フレキシブルですね。
So we have the idea of middleware built in as a way of providing two parts of functionality. One is the extensibility and the other one is the configurability.
そして、ミドルウェアのようなサービスですね。コンフィグレーションや設定を簡単に変えるためです。
So I have some examples here. For example, if we wanted to set a maximum upload size on a per file basis, we can do it by examining the request that originated the handshake of the party syncing process.
ハンシェイクの時にこのようにマックスサイズをサーバーがクライアントに伝えます。
We're also able to for example, decide on a per file basis what the chunk size is going to be and when the file is actually going to expire from the server in the event that the client never comes back with the missing pieces.
ファイル一つ一つにチャンクサイズやいつからいつサーバーのコピーを消す、アップロードができない場合、いつそのチャンクをサーバーに消すの設定もできます。
And finally, very importantly, we can apply any sort of authorization mechanism that we want, including, for example, signatures.
そして、ユーザーの認識もできます。例えば、
signatures.
Signature.
For example, if you've used S3 in the past, you know that they have their own proprietary mechanisms for performing authorization and giving permissions to, for example, remote clients to perform an upload. And those could actually be fairly easily implemented on top of this architecture.
その S3 みたいな認識システムも結構簡単に使えます。
And we're actually going to open source this, which is being implemented right now for the video press platform which is our own implementation of sort of like a YouTube-style video hosting service. And our hope is that by deploying this, we're actually going to make uploads a lot more robust and reliable, and then eventually open sources.
オートマティックの、新しい商品のために開発しています。GitHub すらオートマティックにオープンソースとしてそのパーティーのフレームワークを公開します。誰でものアップロードが気持ちが良くなるように。
Thank you.
ありがとうございました。
質問のすみません、一応10分まで伸ばしているので、質問をいくつか受け付けられると思うので、誰か質問ある方、手を挙げていただいてもいいですか？つべさん。
日本語で、5API とか、そういった新しい API を使うときに、もちろん仕様は固まっているけれども、でもその通りにいくかわからないとか、API 自体が不安定みたいなところで、不安だったりとか、あるいはこれがもうちょっと変わればいいのにみたいな。
ちょっと
I should speak in English maybe?
No, I think it's okay. So when he uses when I don't have a micro. When he uses the HTML5 API, that contains like strange errors or mistakes over time. So will this also cure that? Like when you have the HTML regular file uploaded,
Yeah.
Or microphone here. Just my mouth.
So you're talking about bugs with the file implementation?
Well, I'm actually talking about specifications. So HTML5 API may change over time, and something is not stable enough, and you have some worry about using that API.
Oh, so it's a legitimate concern. In fact, file, for example, has changed a lot over time. Firefox sort of shipped an initial implementation that had one way of reading the data that changed over time. But now the specification is actually solid. In fact, 100% of the cloud app uploads go through a combination of XML HTTP request and the file API. The only concern is right now the stream API is in flux. I haven't had the need to use streams in particular because, for example, you're able to slice the file, and even though it could be like 2 gigabytes, you're able to request only, for example, the first 5 megabytes. So we don't have to actually allocate the entire file. The only part of the API that's sort of in flux is everything related to streams. But we're sort of able to simulate a stream in this way. My experience with streaming the file chunks over WebSocket is a little disappointing in terms of performance. That's why I only mentioned it as a possibility for improving compression capabilities. So I think what we need from, I guess, the standards to improve is the stream portion of the API. Thank you.
じゃあ、あと1個ぐらいかな。それか、一緒に聞いてみたい人いますか？
モバイルブラウザ、iOS とか Android、どのブラウザでも使えるようになります。
Does it also work in any mobile browser?
Yeah, so mobile browser support is actually great. The bottleneck that we found with mobile browsers usually has to do with memory allocation and concurrent uploads. So we stay away from using the multiple feature for file selection on certain mobile devices because the strain that it puts on the phone usually makes the web view crash in many cases. So we do have certain optimizations for limiting how aggressive it is on mobile devices, in particular in terms of concurrency. But all the APIs actually work really well on most mobile phones that we test.
はい、じゃあありがとうございました。じゃあ拍手をお願いします。